Hi everyone, and welcome to the Impression Evidence video lecture. Let's get started. In this lecture, we'll briefly touch on a wide variety of impression evidence types. We'll start with human body prints, including ear prints, bite marks, and footprints. Fingerprints are also covered in this category, but we've already addressed them in a separate video lecture. We'll finish off the lecture video by discussing shoe prints, tire tracks, and tool mark evidence. Ear prints are one of those lesser-known types of impression evidence. Scientists have argued that ear shape is unique to each person. By measuring the distance between different points in the ear structure, a unique ear print can be identified. Due to the uniqueness argument, ear prints have actually been used in criminal cases as a form of identification. However, ear prints are easily distorted by pressure in a way that we don't see with other human prints. The ear structure is mostly unattached from the body, so there's no musculature holding the ear into a specific shape when it's pressed against an object. And that distortion can create substantial measurement differences. My undergraduate honors thesis was actually on ear print identification. I used a postal scale to collect latent ear prints at 3 known pressures, 3/4 of a pound and 3 pounds, and then I compared the print measurements within individuals. The image here is one of the latent prints that I collected. The lines represent the measurements that were taken using a computer analysis program. Now, the goal of my study was to study the distortion between the high and the soft pressure latent prints, and then to compare the consistency of distortion between prints. The 3/4 pound pressure was considered a soft pressure, and then the 2 prints that were obtained at 3 pounds represented a hard pressure, which I believed was most likely to distort the impressions. I found that ear prints did show distortion between the soft and hard pressures, as expected, and they had up to a 140% increase in print area under the 3 pound pressure as opposed to the 3/4 pounds. But I did not find a large differentiation in the distortion between both of the high pressure prints. Now, mine was a small study with a limited number of participants. Other researchers that are looking at ear prints find that pressure distortion can be very irregular, particularly for some types of ears. This creates challenges for investigators who are trying to compare ear prints because there are a variety of factors that can affect the latent impressions that analysts cannot recreate without some known parameters. For that reason, ear print identification is not considered a strong scientific forensic analysis. Instead, trace DNA that's left in the ear print from shed skin cells is of much higher evidentiary value to investigators. In terms of collection methods, latent ear prints are collected in the exact same manner that latent fingerprints are. Physical powders are used to visualize the print, and then the whole print is photographed with examination quality images. If a known ear print is collected for comparison, the investigator should obtain multiple samples at different pressures in order to help aid the comparison. Bite marks are another type of impression that are left by the human body, specifically by the teeth. Biting someone's skin creates a crush injury, leaving a patterned bruise on the skin. These patterns can then be matched with suspect dentition in order to determine matches or to exclude suspects as the source of the bite. Now, like ear prints, bite marks have been used successfully in criminal courts, but today the forensic community views bite mark evidence with a lot of skepticism. Just like ear prints, bite marks are subject to extensive, uncontrollable distortion. Human skin is pretty elastic, right? That's why we can pull it up. So as you are biting into it, that skin is going to distort under the pressure. And this distortion varies between people and between areas. For example, there's a lot more elasticity of your skin on fatty areas, like the butt or the breasts, but there's less elasticity on areas with less fat, like your head or your calves. So that's going to create variation in the bite distortion, even on the same person. For that reason, just like ear prints, today, bite marks are valued more for the fact that they carry potential DNA profiles than the actual shape of the bite mark itself. Now let's turn to another important area of impression evidence, footwear and tire mark impressions. I'm going to start with shoe prints, or footwear. Footwear impressions are a common type of impression evidence that can be collected at a crime scene and can be used to match or exclude a potential suspect. Oblique lighting is helpful in locating footwear impression evidence, as is electrostatic lifters. However, if you plan on searching for footwear impressions, you should do so early in the scene processing because you want to avoid walking over and over and damaging the print. There are different types of footwear impressions. and each requires its own processing method. Positive impressions occur when the footwear deposits something onto the surface that we can collect, like the footprint is made out of dust, dirt, mud, or blood. And that's the most common type of footwear impression. Positive impressions are generally collected using evidence quality photographs and then electrostatic or gel lifters. Negative impressions, on the other hand, occur when the footwear removes something from the surface. For example, if the surface is covered in dust and the suspect walks through it, the suspect's shoe will remove the dust from that area. Usually, the only way to collect this evidence is through examination quality photographs. Footwear impressions can also be two-dimensional or three-dimensional, and they can be made of wet or dry materials. And I'll discuss some of the processing concerns related to these characteristics on the next few slides. Now, two-dimensional shoe prints have length and width, but they are not three-dimensional. These can be collected like fingerprint evidence. The photographs you see here are called a gel lift. A gel plate is laid against the impression and a roller is used on the back of the plate. This pressure helps the particles from the surface adhere to the gel. The plate is then lifted from the surface, covered with a clear protective plastic, and photographed for preservation. Electrostatic lifting is another method of gathering shoe print evidence. This method works in a similar manner, but it uses an electric current that's applied to the plate that is then set on top of the impression. This creates a static buildup, and it causes the particles to cling to the lifting plate. Electrostatic lifting can lift footwear impressions from a variety of surfaces, including carpet, tile, and other flooring. Electrostatic lifting can even be used to lift impressions that cannot be seen by the naked eye. But again, protecting areas of potential transfer is key because people moving across the surface is going to ruin the impression before you get a chance to collect the evidence. So if you plan on collecting footwear impressions, make sure as minimal walking through the scene as possible and stick to one single trail so you know where your investigator stepped versus the suspect. Three-dimensional shoe prints have a depth to them, so different collection methods are necessary to preserve all of the details of the print. For three-dimensional prints, casting is the most common method used to collect unknown prints. A rubber or a plastic cast is mixed at the scene and then applied on top of the three-dimensional print. Once it's dry, it creates a three-dimensional cast of the entire print that can be photographed and compared in the laboratory. Casting can also help lift trace evidence that's contained within the print, like minute hairs, fibers, or tiny pieces of glass that were transferred from the bottom of the shoe to the top of the surface. In order to compare a three-dimensional cast, investigators will use biofoam to capture a three-dimensional impression of the known shoe in order to compare the tread with the collected unknown print. There are several things investigators must keep in mind when collecting three-dimensional footwear impression evidence. First, it's essential to photograph the impression before and after casting. Before applying the casting material, initial photographs should be taken using oblique lighting to highlight the depth and the detail in the impression. Once the cast is complete and fully dried, another photograph should be taken to document the final result. This ensures that investigators have a visual record just in case the cast is later damaged or it degrades. Another critical step is to avoid cleaning off the cast after it's removed from the scene. Investigators should never attempt to wash away the dirt or the debris because these particles may contain trace evidence that's useful in the investigation. Any material that adheres to the cast should remain intact and packaged with the cast until examined in a forensic laboratory. Finally, investigators must allow the cast sufficient drying time and store properly in order to ensure the impression evidence is properly reserved and remains valuable for forensic analysis. Casting materials can take several hours or longer to fully set, depending on the environmental conditions. Handling a cast too soon can cause cracking or warping of the cast, and that can compromise ridge detail or tread patterns. Plastic bags should never be used for cast storage because they trap moisture and that can cause softening of the cast or create mold growth. Instead, casts should be stored in breathable paper bags or boxes to maintain their structural integrity. Now, another important type of impression evidence is tire tracks. Tire tracks can be 2D or 3D and are treated much like footwear impressions in terms of casting and documentation. But there are a few unique challenges to document tire track evidence. The goal, if possible, is to individually document each tire. This means ideally we would look for impressions where the car was turning, because this provides us with 4 individual tire tracks. If the car goes straight, then the back tires go over the front tire impressions, and that makes it difficult to identify individual impressions. So investigators need to be aware of the vehicle's direction of travel when determining what part of the tire track to capture. Another unique documentation challenge for tire tracks is that they require a larger than normal area of collection and documentation. Our goal, if possible, is to document the entire circumference of the tire, not just the portion that's on the ground at one specific moment in time. In order to document the entire tire, investigators typically document about 8 to 10 feet of the tire track impression. Now, because we can't take a high-quality photograph and capture all 8 feet at once, investigators have to document the tire track in smaller sections. As shown on this slide, the photographer will split the tire impressions into multiple segments, making sure to overlap each segment so that the images can be correlated with one another. Tire tracks should also include a continuous scale for the entire impression, as well as individual rulers and evidence markers to categorize each individual segment. You should also take at least one overall photograph that shows the whole tire track, so that way that you have a reference frame for where those close-ups come from. Like fingerprint evidence, tire tracks will require a known impression to be collected. This can be collected using black ink and butcher paper, as shown here in the photograph. Just like the unknown impressions at the scene, the known impressions will be approximately 8 to 10 feet long so as to capture the entire circumference of the tire. Now, care should be taken to ensure that prints come from only one tire at a time. So, as you're collecting, as you're moving the tire, you may need to roll up the butcher paper as the tire drives over it so that it doesn't get run over by the other tire and added too many tires to the ink. For tool marks, the standard collection method is to cast the tool mark and collect the cast. You should also take examination quality photographs of the tool mark itself with oblique lighting and examination quality photographs of the cast. That way, again, just like footwear, if something gets destroyed on the way to the lab, you still have the photograph to work from. If there is a suspected tool of origin, the best practice is to take the entire tool back to the lab. An examiner in the lab will use the tool to make similar impressions, and then they can compare the two casts. At no time should you ever fit the tool into the impression at the scene. This can damage the tool mark and destroy your evidence. So remember, tool mark by itself, tool by itself, leave it to the lab analyst to compare cast to cast. Never put tool mark into the actual, or the tool into the actual tool mark and go, hey, it fits. Not good. All right, well, that's it for the impression evidence lecture. Thanks for watching, everyone.